Hi everyone, Harry Frank here from Red Giant. In this tutorial, we're going to be talking about motion paths in Trapcode Particular. This is a curious little feature found in the physics section in Trapcode Particular, and the way it works is fairly unique, but it has a lot of applications, especially if you need to guide your particles along a very specific path. And this works really well if you're trying to integrate movement within 3D. Even if you need particles to go behind things and you're perhaps working in Cinema 4D. And we'll go through some examples of this using Cinema 4D Lite and creating some particle swirls around objects. But let's start with the simple part of what a motion path is and how this differs from the standard light emitter that you might use in After Effects. So I'm going to steal this little blue background to make things look a little more interesting. And let's create a solid. I'm going to use the quick key to apply my last effect, just apply particular. Now, in other tutorials, we've learned about using lights as emitters within particular. In fact, this is a very useful feature. If I create a light and I name it emitter, I can use this light's 3D position to dictate where my particles are generated. So I'll go to my emitter type and set this to lights. And if I animate this, we'll see that the space in which particles are generated will follow the light. However, motion paths are very different from this. In this case, we're defining the emitter position. So this is where the particles are continuously generated. As they are created, they continue to move outwards, but the light emitter itself doesn't affect the path of the particles. The particles are not flowing along this path. The area in which the particles are born is just being dictated from the 3D position of the light. So not to be confused with light emitters, motion paths are a very, very different thing. So I'm going to take this light and rename it, and I'm going to call this motion path 1. And I'll make a path that's slightly interesting here. So now, in particular, I'm going to close out the emitter section. And we are actually, well, first, before I close that out, I need to set this to something that is not lights. That's very important. We're not using a light emitter. We're using the spline of the motion path to define the flow of the particles. But how they emit is still defined in the emitter section. And we do not set this to lights. So I'm going to set this to point for now, and maybe we can change this up a little bit, but point is just fine. So I'll go to the physics section under air and select motion path 1. You'll notice that we've got lots of room for additional motion paths with additional uses of particular, but I'm going to just use this one right here. The difference between the 1 through 9 and the HQ versions is that the HQ versions are slightly slower but do a more detailed subsampling of the motion path. But generally, you'll find that the standard motion paths will work just fine. So you'll notice immediately that my particles are taking on a flow that mimics the overall path of my light. Now, it still has its default velocity of 100, so they're flowing along this path, but they still have a bit of velocity. I'm just going to turn this down. Like I mentioned, the speed at which they flow along the path is dictated by how fast this path draws on. You'll also notice that the paths are not in alignment whatsoever. So again, the motion path is just dictating the flow of the particles, but where the particles are being generated is up to the emitter section. So the emitter section and the motion path are two totally different things. But if you want them in alignment, all we need to do is align this emitter position with the starting point of the light. So right now you can see we've got some fairly random values, but I'll just copy and paste these in here. We can align these with expressions if you want, but that's just a bit tedious for this right now. There. So now I can see that where my starting point is aligned with where the particular universe is. You notice that the particles are stopping prematurely, and that is because they just don't have enough lifespan to make it all the way to the end of that spline. The spline length is at 4 seconds right now, so they're stopping a little bit short. So as they flow along this path, There is no more position information for it. It stops there, so that's exactly where the particles stop. So how is this useful? Well, as the particles flow along this, they have their own velocity, we can set these particles to something like a custom particle, like an arrow, and show direction. We can show a sort of flow along this path. So if I go in here and I set this to a sprite colorize, and I choose a sprite from my particle library, let's just use the basic arrow. And we need to fix a few things here. We need to make it a little bit bigger. I'll go to the rotation section and set this to orient to motion and rotate the overall angle of the arrow 90 degrees because its initial angle is facing up. So we need to point it to the right. I think this is quite a bit of particles for what we're trying to show here. So I'll knock this down to maybe 25 particles per second. And now we can see that we've got particles flowing along the path. Now there's a few quirks to this, and this is just not exactly a bug. It's a matter of working with the math rather than trying to work against it. When we select that feature right here, which I said is orient to motion, keep in mind at frame 0, there is no motion. It has not started moving as of yet. So there's no motion for it to orient to at that point in time. You might be saying, well, why is that a big deal? Well, you'll notice as I scrub forward, the very first particle that gets generated on that frame 0, where there is no motion, is not aligned with the rest of the particles. Now, there's a couple different ways to fix this. The easiest fix for this is to simply keyframe the particles per second from 0 to the value that you want. So if I go back to frame 0, I enable keyframes for particles per second, set this to 0, and then animate it to 25, and I scrub forward in time. You'll notice that it essentially skips that first frame. But if I change my particles per second here, it's now going to animate between 25 at frame 1 and then all the way to that change that I made later in time. And I don't like that. I don't like having to go back to frame 1 every single time I want to make a change to my particles per second. So there's another way to do this, which is to use an expression. So I can keep my existing value, and I can just use an expression to say, if we are at the time of the endpoint of the layer, so no matter where I move this in time, if we're at that time, set the particles per second to 0. So I'm going to turn off all of my keyframes, Option or Alt click on here, and we're just going to use an if statement that says, if something is true, do something. So if something happens, and we'll put that in here in parentheses, if that is true, set the particles per second to 0. So that's what we will output if this stuff in here is true. If it's not true, then output something else. Now I could say 25, and that would leave it as a fixed value of 25. Or I could just say value, and that will be using the existing value before the expression. So if something is true, set it to 0, else use the existing value. So I can say, if my current time matches the endpoint of the layer, then output 0. So that's saying we're at the very first frame of the endpoint of the layer. So the way we measure time is with the word time. Time is a reserved word for the current playback time. If that is equal to, now it's just a JavaScript thing. You have to use 2 equal signs because 1 equal sign is used to set something equal to something else. 2 equal signs is to test if something is equal to something else. So if time is equal to endpoint, lowercase I, capital P, endpoint is equal to the start time of the layer. So this makes it flexible. If I move this layer forward or whatever, I'm not saying if time is 0, because if I move this layer forward, then, well, time isn't a 0 here. It's actually 1 second, 25 frames. So if I just say the endpoint of the layer, this will cover all of our bases. So you notice now that it generally works. And I say generally because in theory, it's still working. You might every now and then run into one little straggler. And this, honestly, I don't know the math behind this. But if you do see one little straggler like this that isn't quite lining up, and I can make this a little more obvious by setting this to a box, and we'll set this to 0 and 0 in Z and maybe 25 in Y, so we can kind of spread these out just a little bit. They're mostly pointing the right way, but there's sometimes one little crazy particle that is oriented just slightly the wrong way. So if we go into emission extras and go into periodicity random, which is essentially a mini randomness control for the random seed within particular. If you set this to something that isn't 0, this will snap that one stray little particle back into place. And this isn't something that's unique to particular or any sort of bug. This is just a math kind of thing you'll find in After Effects, even using orient to motion or orient along path, where you have 0 velocity. There is no motion to measure at that point in time, so you kind of have to work around it. So I mentioned being able to use something like this as a 3D path using Cinema 4D Lite. So included with After Effects is a Lite version of Cinema 4D. In fact, you can create a new Cinema 4D file right within After Effects, and you can select File, Maxon Cinema 4D file. And we'll just call this like cylinder vortex. All right. Now, not that I want to turn this into a full-on lesson about how to use Cinema 4D, but I will cover just the basics of what I set up in the scene that I was showing you. So I'm going to work with a cylinder, and we're going to have air flow inside this cylinder. In fact, it's going to flow around a center object and will contain it within a larger object. So I have my internal cylinder right here. This is where the air will be flowing around, or my particles. And I'll duplicate this. We'll just make a copy of that. And I'll make a larger one just by dragging this out. So I'll put 2 different shaders on here. So I'll create one shader for the outside. We'll just drop this on there, and we'll make this slightly transparent. Go into my transparency, and we'll have this mostly transparent. And on the inside, we'll just create a very plain, flat blue texture. So I'll apply another material, and we'll go to its color. Just set that to blue. I'm going to make sure to make a camera for my scene, and we'll look through it by clicking on this icon right here. I'm going to create a null object, and we'll use this to locate the center of that blue object that we want the particles to swirl around. So I'll go in here, create a new null. That kind of defaults to the center, which is right about where I want it, but I want to move it down to the bottom there. I'll jump to a different view and make sure I'm kind of aligned near the bottom right there. And I'm not really going to animate anything within Cinema 4D. I'm just going to make the airflow of the particles around these objects all in After Effects. But to prep things to get into After Effects, we need to check a few things. First of all, we got to make sure that our actual resolution is ready for video. And 800 by 600, I don't think is going to cut it. So we'll use an HD TV 1080 2997. I'm going to set this to render all frames, and we'll make this length maybe 150 frames in length. Now we'll come back to this, but there's a couple specific things that we need to do to our objects in here. To see our null show up in After Effects as a 3D null, we need to apply a certain tag to this. I'm going to go to Tags, Cinema 4D, and select External Compositing. And this will tell Cinema 4D to take this object and have it show up in my After Effects scene. I also need to have a separate alpha channel for this blue object here, because I want my particles to interact with it. So when we bring this over to After Effects, we're not really bringing over geometry, but we're bringing over layers for After Effects to work with. So I can define this cylinder here to render as a separate little element with its own little alpha channel. And the way we do that is by rendering this single object to the object buffer. And that might sound complicated, but all we need to do is go back to that tags section with that cylinder selected and go to compositing. At the very last tab of that compositing section, we have this thing called object buffer, and I can click on enable, and this is going to render this object to object buffer number 1. All that means is going to do a separate pass of the alpha channel of this image. That's really all it's doing. Now, it won't do that unless we enable multipass rendering. So I need to go in here, select multipass, and I need to click on multipass and tell it to render both the RGB image and the object buffer. So it's going to render 2 different passes. So it's going to render the full image of all the stuff that we see and the object buffer. There. Seems like a lot, but it's pretty standard Cinema 4D stuff. Now over here in After Effects, I already have this file imported because I created it within After Effects. If you wanted to import it, you can simply go to File, Import. So I'll take this, drag it onto a new composition, and there we see our scene. If I go into my Cineware controls right here, I can click on Extract, and this will get that null object that I created and the camera from my scene. If I switch my renderer to a standard, either draft or full, I can add my image layers. So this is the multipass layers that I defined earlier. And I need to check defined multipasses, and this will just add the 2 that I have set up in Cinema 4D. So I'll say add image layers, and now it's showing me my RGBA image, and that's this render right here, and then this object right here. This is an isolated matte of that object. So I'll just turn that off. Okay, so let's create a layer for particular, apply the effect, and I'm going to set up the motion path. So I got my null object right here. I didn't animate it in Cinema 4D. I'm just going to use that null and animate my light. This will be motion path 1, and I need to align this to where that null is because we've got slightly different space here. After Effects space and Cinema 4D space don't always line up. 0 and 0 is actually right here in Cinema 4D, whereas 0 and 0 is right here in After Effects. So my light is probably somewhere off screen. But I can simply align it to that motion path by parenting it and holding the Shift key. And that will snap it right to the center of that null. And then I'll move this light just a little bit off center. So we're going to have our particles kind of start there and swirl upward in this cylinder. So at this point, all I need to do is animate my null position and rotation. So here's my null position and Y rotation, and we'll have this go over 4 seconds. We'll have the Y rotation do maybe 3 full rotations, and we'll have it move from the bottom and then all the way up to the top. So as I scrub through this, we should see this light spinning just like so. There. So that is going to be our motion path. So I'll go to Particular, go to Physics, Error, and set this to motion path number 1. Now, if we don't see anything just yet, we're not going to panic. Remember how we have to align the world of Particular to the world in our After Effects scene. Now, this gets a little bit complicated because we've got Particular space, we've got this light space, which is parented to this 3D null. So where do we get our 3D? Well, we kind of have to estimate things unless we want to get into very complicated expressions, but this isn't very difficult to estimate. The 3D space we need is going to be pretty close to this null's starting location. So let's look at this null location. So it's 0, 260, and 0. So let's start there. So I'll go to Emitter, set this to 0, 260, and 0. Now as we scrub forward, we should start to see some particles rendering. Let's set this velocity to 0. These are essentially emitting from the center here, and we need to move it in its x-axis to be where that light was. So from here, I'm just going to go into the emitter position and scoot this over in the x-axis to kind of get it where it should be. In fact, I can go to my different views here. I can look at the front view. Let's move this around using my camera pan tool. And it should look like the particles are centered right around that spinning null object. Looks like they should be kind of scooted over just a little bit more. Tap the escape key to get to our last camera view. So I think we pretty much got it. All we need to do is define that object buffer that I rendered to knock out the particles. Now this isn't going to be a mask, because as you look closely, we should have particles in the front and we should have particles behind it. Now I could fake this using an obscuration layer, but that is kind of faking it, and I don't want to fake it. I want to do it the right way. So we're going to use a different feature here. We're going to use the Z buffer instead of the obscuration layer. The obscuration layer allows us to obscure particles with After Effects 3D layers, like flat layers. So what the Z buffer is saying is that there's an object in 3D space where our particles should be obscured and can go behind it and in front of it. We define that object in space using black and white. So first I need to define that layer. So we'll define the object buffer as the Z buffer layer. Now notice it's knocking everything out. So I need to define where in Z space, so essentially the distance from our current camera to where this object is in space. So what that distance is what this white value needs to be. Again, this is what our object looks like. So this is white, and we need to say where in space is this white. Now we could do expressions to measure the distance between the camera and this null object right here, but really what you're going to end up doing is just kind of knocking this value up and up and up until you find the particles pop right in front of the object. Now in the basic scenes that I've set up like this, it's pretty consistently just above 1000, somewhere around 1200. So if you get it too high, all the particles are going to go in front. If it's too low, all the particles will go behind it. So right around 1200 is exactly where that object should be in space. So what this distance is saying the distance between the camera, which is here, and where this object is supposed to be in space, which is essentially where this null object is, that distance in pixels is 1200 pixels. Again, After Effects is pretty much the only program that I know that measures units of distance in pixels. You know, when you get into Cinema 4D, you're working with meters or centimeters or millimeters, but After Effects uses pixels. So sometimes you just have to guesstimate. So again, we can go in here, we can set this to some sort of custom particle. So go to Sprite Colorize. We'll set this to our nice little arrow, basic arrow. Turn the size up just a little bit. We'll set the rotation here in the rotation section by setting it to orient to motion and set the rotate to 90 degrees. So we want a little bit of that variation in there, so it's not just one single point drawing on. So I'll set this to box XYZ individual, set X and Z to 0, and we'll set this to, I don't know, maybe 80 pixels tall or something like that. So now we see we've got the particles swirling and moving along that path. So again, this is about what it looks like. This has a second system with some basic spheres in it. Just adding a little bit more of dust or debris in there. There was another example that I showed here using a simple pipe like this. Now again, I could animate this in After Effects, but in this case, I chose to animate the light right within Cinema 4D. I said I didn't want to turn this into a full-on Cinema 4D lesson, but just to do a quick overview, in this case, I have an object that is using a sweep, so it's drawing a circle along a spline. So I have my spline right here, just looks like that. I have a circle that looks like that, and then a sweep. When I put both of these inside the sweep, it essentially draws an object, it draws geometry using those two splines. Taking this spline here, I can create a light and use a tag called align to spline. And if I animate its position from 0 to 100, that light will animate along the spline. So the geometry and the light will share the exact same spline. So this is a good way to get a motion path right into After Effects. Now what you need to do is take this tag and actually turn it into keyframes. And you'll find that under the timeline, functions, bake objects, and then you're going to hit OK right here to take that spline right here and turn it into keyframes, and it creates a copy. And that's exactly what we're seeing right here. Motion path 1 copy. And this is essentially written to keyframes. You can see all the keyframes written over time right down here. So when I import that into After Effects, I get the motion path Lite, which has all these baked keyframes. And then I can do the same thing that I just showed you before, which is assign this as my motion path and have arrows or whatever travel along the same geometry. So those are motion paths in general. They are pretty fun to work with and definitely worth exploring if you're working with 3D scenes imported from other software, especially as I showed you right here using Cinema 4D Lite, which is built right into After Effects. So that is the topic of motion paths. My name is Harry Frank for Red Giant. We'll see you next time.